Oh, well, tēnā rā tātou, tēnā rā tātou, tēnā koutou, te whānau kua piri mai mā te purangi. So it's my pleasure. I'm going to introduce Nick. I just said to Nick, like he's got such a list of amazing things he's done. He's a senior lecturer in physics from the University of Auckland, but the most important fact about Nick is he's one of us. And he's Ngāti Mutunga and he's of Taranaki descent. And so I'm going to invite Nick to talk a little bit about his background, and then he'll go into his presentation. So, nō reira, tēnei te mihi ki a koe, Nick, so hara mai ki tēnei tāwhia.
Kia ora koutou kua hui mai nei. E mihi ana ki ngā mana whenua. Ko Nick Rattenbury, tōko ingoa, ko Ngāti Mutunga. No Tamaki Makaurau, aho. No reira, kia ora koutou katoa. Thank you very much indeed. This is indeed a privilege for me to be here. This is the first time I've been here at Uranui. My family history is probably actually better known by people in this room than me. And that says not a lot about me as a person, unfortunately, but I'm here now, and I feel quite privileged to be here. And I'm delighted to finally, far too late, started the process of connecting with Ngāti Mutunga. The welcome so far has been just incredible, so thank you so much. The history is, I reached out to Mitchell to say, look, I'm now finally at a position at a university where I feel like I have some influence. It's only taken, yeah, exactly. It's only taken this long, right? And now I want to use that influence to do what the universities in New Zealand say they want to do, which is to reach out to iwi and say, well, how can we join in the process of learning together? And so that's part of my job now. I say it's now part of my job, and no one's stopping me. So that's part of the reason why I'm here, is to connect and also to bring something, and also to see, you know, how can we go forward together. And so when I spoke to Mitchell, first of all, I said, well, what can I do to help? And he says, why don't you come on down and talk about Matariki? I said, sweet, let's do that. All right. So I'm here to talk about Matariki and Puanga. And I was saying, you know, just before at tea, I had never expected to be in a position seeing this country celebrate a Maori holiday. And that's something which really got me. So part of my background is, for the first part of my life, when I was roughly this one's age, I thought I was Australian. I was born here in Takapuna in Auckland. I was 2 years old, taken to Australia. And I grew up Australian, for my sins, I guess. But I thought I was Australian until I was about 10, when my parents decided to take us off to England, where I developed this accent, whatever it is. And in that process, they said, oh, here you are, son, here's your passport. And it said New Zealand on it. I'm a New Zealander. That was sort of my process. Went to England, got this accent, came back 6 months later, and then grew up further in New Zealand. Went back to England as a researcher for 10 years, still with a weird accent, came back now, basically recruited back to the country about 8 years ago to continue my research. So that's a bit of my background. So I did my degrees at the University of Auckland, went off to Manchester, briefly moved into law, and then I was recruited back to the country to continue my research. My research is in discovering planets, which is kind of cool as a job. It sounds really cool when you express it. What it really means is I sit in front of a computer and I write computer code. And I try to make the computer do what I want it to do, like a lot of science. And it's only these sorts of times when I can come here and talk about this stuff where I get excited about it, because frankly, you know, computer code is great and everything, but it's... You know. So I'm currently a senior lecturer in the Department of Physics. I'm also part of a new institute at the University of Auckland, the Te Pūnaha Atea Space Institute. I'll talk a bit about that later. I am the science lead for the Auckland Program for Space Systems. Again, I'll talk a bit about that in a minute. I'm also part of Te Ao Marama Centre for Fundamental Inquiry. Now, this is something which quite interests to probably folk here, is that we are trying to develop a transdisciplinary research community, one where we want to hear from everybody. It's not just people from science, from mathematics, from engineering. We want to hear from everybody about the things which they're interested in, the research that they want to pursue, and how the university can help. So it's a group of like-minded academics who are just cool and interested about everything. And it's really neat when you have a group like that, when you say, hey, what are you interested in? Well, I'm interested in this. Well, that's not what you're trained to do. I don't care. I'm interested in it right now. That's what I want to do. And so there's a group of us who feel we've given ourselves permission to talk and think about these things, which is kind of what you want a university to do. I'm also a past president of the Royal Astronomical Society of New Zealand. I'm still on the council, and proudly I am Ngāti Motonga. So this is me at the office where I really prefer being, on top of a mountain with a telescope. I'm part of the Japanese, US, New Zealand collaboration called MOA, and our job is looking for extrasolar planets. So planets going around stars other than our own sun. So when I first started my research career, we knew about the planets in our solar system, and that was it. Now we know over 4,000 other planets in our galaxy. So what we've learned over my lifetime so far is that this weird experiment, which is going on here with this planet and the weird things which grow on it, like us, is probably not rare. There is probably life out there. You can ask me if I think aliens exist, and the answer is yes. I really do think that's the case. Do I think we'll ever see them? Probably not. We can discuss this, but yeah. So this has made people think about things in different ways. It's like, this is not the only place in the universe where this weird experiment that the universe has conducted has taken place. How does that make us feel? We use a range of telescopes. So this is a telescope at the Mount John Observatory in Canterbury. This is the biggest telescope in the country. We use it to find planets. And later on this decade, this telescope will fly. This is the Nancy Grace Roman telescope, which is a new NASA telescope, which is being launched 2025, hopefully, which will also be looking for planets using the technique which I use, and also a technique which Pauline Harris, who may be known to some of you, who has been active with the SMART program. She and I are of an age, and we started off looking for planets as part of our research career, pretty much at the same time, using the same technique. The technique for finding planets that the MOA collaboration uses, which this big telescope will use. So I don't want to talk too much about that particular technique. I want to talk a little bit about the motivations that I have and present that to the iwi here by means of introduction and also as an invitation. So when I start off, or when anybody starts off a research career, they're like, I'm going to go and do this one thing. I'm going to do it very well. I'm going to become the best in the world at it, and that's it. And then you get older. Yeah, brain starts to slow down a wee bit, and you discover you spend more time with spreadsheets and emails. And spreadsheets and emails are really important, but they're there to make it possible for the younger people and other people to do their research and say, right, well, my job is to find money to get the research tamariki, the people who I'm trying to bring up, and say, right, it's actually over to you and your smart brains, and you can stay up until 3 in the morning doing the code because I'm tired, I can't do that anymore, but I'll get you the money to do it. So my motivations have changed somewhat from I'd much rather be doing the researchy stuff, I get it, but my job now is to make it possible for other people to do it in this country. So I've been born and raised here. I've seen what it's like to research elsewhere. I have come back knowing what it's like to come back to New Zealand. And I know what the challenges are. At least I know what some of them are. One of them is money, one of them is society, and one of them is culture. And so coming back into the country, knowing what I'm walking into was a conscious decision. It was, I want to come back and I want to help. So my motivations are in scientific discovery. That's my background. I was steeped in this for 20 years. I mentioned that my research is in extrasolar planets, finding planets, which has been great fun. No, I don't get to name them. Shame, but I work in this area called transient astrophysics, things which happen suddenly. So you go and take a look at a galaxy, for instance, through your telescope last night. You go take a look at it tonight. It's probably still going to be there. Hopefully. If it isn't, big trouble. But this sort of field here, I'm interested in things which happen over the timescale of hours, possibly days. Those are typically things which explode, which is kind of neat. So you're looking for things in the universe which are blowing up. That's quite fun. I'm also interested in looking at how humans and machines can discover things together. So your phone and your, I know, your phone and your computer actually know a lot about you. If you ever do a Google search, it's like, oh, no, I've already bought one of those. I don't need another one. Thank you. That sort of work is of interest to me, not the selling stuff, but the way that our devices now can help us discover things much faster than we possibly can ourselves. So this is sort of artificial intelligence, machine learning, because it's part of what I do for this work up here. So this is kind of the stuff which I'm into, scientific discovery. How do we discover things? And I mentioned before, this point in my career, I've got maybe 20 years left. It's now time to do this thing here, sort of capacity building, making it possible to do this stuff, or making it easier for young people to get into it and to develop their skills and to do this research here in this country. And so that breaks down into education, access, and infrastructure. So this means education we understand, getting people learning the stuff that they need to learn, and discovering what interests them and maximizing that, as opposed to you should learn this stuff. When somebody comes to me and says, hey, I want to do this, it's like, oh, okay, great, that's great. If somebody comes to me and says, well, what can I do? It's like, well, actually, what are you interested in? What drives you? What's your passion? We start there. Because certainly as you go up through degrees and what have you, if you're not into it, you'll crash out. You just won't get up Monday morning and say, the hell with it, I can't be bothered anymore. So when you have to do work at progressively higher levels, you have to be committed to it, because there are going to be bad days. And those bad days can actually seem quite terrible. So learning what it is to educate, we're looking at processes like ACO, which is a fantastic concept where it isn't just a one-way transmission of knowledge. It is a joint discovery journey where you're saying, well, I can stand here, I will stand here right now saying, I don't know everything. I promise you, you can ask me questions which I won't know the answer to. I can promise you that I will also say, I don't know, but I'll help you find out. Access is another thing, again, an aspect we'll talk a little bit later. And infrastructure, building stuff. Turns out if you want to do cool stuff, you need bits of kit to do it. So one of my research activities, talk about this is the stuff which I get paid to do as my day job, which is kind of neat. I've spoken about finding planets. I also develop new propulsion techniques for pushing spacecraft around. Do a little bit of research in aerospace materials, and the thing I'm paid mostly to do is figuring out how you can talk to spacecraft with lasers. Instead of radio, let's use laser light. Much faster. Morse code is one way of doing it. Yep. You're not going to speed up your cat videos though. So but in principle, you're right. You're basically going flash, flash, flash with your laser to a spacecraft. Not aliens. Not aliens. So I've got some pictures here. So this is an artist's impression of an extrasolar planet. We don't actually get pictures like this. This is the sort of planets that we find. And our artists say, well, it probably looks like this. Okay. This is us testing some material for bringing spacecraft back through the Earth. When you do that, things get very hot. You've seen the pictures of the Apollo spacecraft. When they come down, they get very, very hot. That's fine, as long as it doesn't get too hot inside. So you cook your astronauts, because that's bad. So we were developing ways of using the material that we have in this country. And this is a key thing. It's like New Zealand just happens to have a pretty good titanium industry. And we've learned how to print it in 3D. So we've been doing work with our German colleagues, because they've got these fantastic wind tunnels, which simulates what it's like to come back through the atmosphere. We have experiments where this beautiful purple glow is like what you see in Star Trek, kind of, is this sort of propulsion using plasma, this weird fourth state of matter. And then here's an artist's impression again of lasers going blink, blink, blink between Aotearoa and a spacecraft. All right. So career highlights, things which I feel proud of that I have done so far is I was part of the team that discovered the first planet using the particular technique that Pauline and I shared back in the mid-90s. So we were part of the team that discovered that first extrasolar planet using that technique. And I was also part of the team which sent this spacecraft into orbit. This is the first scientific spacecraft launched by New Zealand, Aotearoa. And it's tiny, right? So it is about that big. Whoa. Yeah, so this is called a CubeSat, as in it's a cube and it's a satellite. And it's APS-S1, This was built by undergraduate students. So not weird old men like me in a lab coat, but by our students. We gave them the opportunity to design a mission, and we said, okay, design a mission, come up with a business case, tell us how it's going to work, go. And they went, how do we do this? Nobody. This is part of the New Zealand thing. We just figured it out. We had to ask a lot of people. We had to work at it. We launched it, and it was on a Rocket Lab launching at Amahia. So that was quite exciting. So there's a lot of activity going on in New Zealand in space and astrophysics. And I'm not going to go through all of this. There's a lot of words. I just put in a lot of words up there to show you that I went through, and I just chose the ones which I knew about. It's not a complete list, just in case anybody on Zoom, for instance, or the recording gets upset. I didn't put everything on there. But in education at the universities, you can go and study aerospace engineering. You can go and study astrophysics. You can study astronomy. So this is stuff that we can do and have been doing in this country for decades for astronomy and astrophysics. But now we're getting into teaching how do we build stuff that goes into space and survives. And so if you're interested in any of this, if you know anybody who's interested in or looking at getting into this stuff, then feel free to come and talk to me about it. I induct people into the universities, and I actually don't have to get them to go to any particular university. I don't care. I'm from a particular university, but I'm not married to it. So I just want to see people get to where they want to be. We're doing a lot of research, which is space related. So I've mentioned, talking to spacecraft with lasers, looking at this stuff, sort of astrodynamics, and this thing here called space situational awareness. I'll highlight. It's getting really crowded up there. There's a whole bunch of junk up there. And of course, we didn't help because we put a satellite up there ourselves. But it was part of my job to work out the physics of when it's going to come down. Because part of the deal was we could build one of these things and we could send it up there, but we are responsible for it. When I say we, you all are too as well as New Zealand taxpayers. So we got a payload license, which basically says whatever happens to that thing, we as a community are responsible for it, which makes us one of the more responsible communities in the world launching stuff, because we all agree we have the legislation in place to allow this. So it's up to people like me to say, okay, we send it up here, up into space, what's going to happen next? And the thing will come down, it will just burn up, rest assured. But looking at this sort of stuff and making sure that we as a community are doing the stuff in the regular, doing the stuff properly is one of those things that New Zealand has started to learn how to do. What else? And in industry, this is what's happened after, along with Rocket Lab USA, which is the launch provider launching out of Amahia, launching stuff into space. There's now a great deal of interest in space science technology in this country, and a whole bunch of companies have showed up and started to operate. So this is activity which is beyond just the astronomy and astrophysics, but also space technologies. And you'll see the reason why I'm trying to get to this in a minute. One thing which I touched on earlier on is like, whatever we choose to do in space, it has to accord with our values as a nation. So something which I'm very much aware of is that there's an economic multiplier. Right, space is expensive, and if you build something that goes into space, you can charge a lot for it. You can make a lot of money. Great, but doing stuff in space comes at a cost. So here's a neat image here, which I just like to share with you. You can see this is a lovely picture of the stars. There's Southern Cross. One of these is a spacecraft coming back through the atmosphere, getting really, really hot. Not too hot. It went to a nearby asteroid and it picked up some of the earliest material ever made in the universe, right? And it brought it back to Earth for scientists to discover. And it landed somewhere in Australia, I believe. The other one is a Starlink satellite. So these are two uses of space. One is something coming back, carrying a scientific payload, and another is a commercial entity. So they're both, if you like, scarring the night sky with a star trail or a track like this, one of which is for one purpose and one is for another. And it's difficult to try and sometimes figure out, what is the value here that we as a nation are going to see. One of these I can get behind completely, right? Getting this stuff back and analyzing stuff which is 4.5 billion years old to try and teach us how we came about as a weird little rock around our sun, and the other is Stalin, like faster cat videos. Okay, so it's challenge. You have to figure out what is the value to. Maybe yeah, there'll be a lot of SpaceX fanboys who'll be shouting at me right now saying it's the best thing ever, but I didn't sign up for this. Okay, so sustainability. So I will get to Matariki, promise. Promise, sorry. But I just wanted to point out that there's a lot here that enjoying things like Matariki and Puanga, talking to Pauline, talking to, we have researchers who are looking at this sort of effect on, for instance, Matariki. That's important. And so this is work which I kind of involved with, led by Puanga at Auckland, looking at how do we do this sort of stuff. If we want to get to space and do this sort of stuff out here in New Zealand, how do we make it sustainable? How do we make sure that we utilize the natural environment, but we don't damage it permanently? So I just want to try and, when you come and give these sorts of talks, and you say, oh, well, he's building spacecraft and he's throwing things up there and stuff like that, that's great. It's always mindful of the cost. So that's kind of trying to reassure folk that when I give these sorts of talks, that mindful of the tiakitanga that we have to be aware of. And the government is aware of it. So this is Nania Mahuta talking in response to the signing of these accords here, the Artemis Accords. The Artemis Accords is a set of legal agreements, if you like, between nations who operate in space, and now New Zealand's one of them, talking about how we're going to do this in a sustainable fashion. Now, I'm not going to get too much deep into this because it's a little bit contentious, but the concepts of kaitiakitanga of the space environment is something which this government is aware of. Probably because we've made them aware of it. So if you put stuff up there, you're responsible for it, and you're responsible for that environment, which we consider to be a natural environment. Certainly you talk to an astronomer, my astronomer hat on, I don't want to see too many of those star streaks that don't have to be there. Okay, so into the good bit now. Outline of this talk. I'm going to be talking about the astrophysics of Matariki, the astrophysics of Puanga. I'm going to try and do a quick demonstration of how you can integrate with a particular piece of software. It's for free. You can play around with it. You can see Matariki. You can predict what is going to happen yourself. I've spoken a little bit about university engagement. I will take a lead. If anybody waves at me and says, get off, that's just tell me. But it's time to get into the cool star pictures. So my background is firmly in the study of astrophysics, physics, computer science, mathematics, and statistics. As you can tell by my pronunciation of my pepeha, I'm only at the start of my Te Ao Māori journey. So this is my background, this is where I've been brought up, and this is what I'll be focusing on. So here's Matariki, beautiful, beautiful cluster of stars, known since antiquity, and as you know, just about every culture who bothered to look up has got a name for it. One of the people who bothered to look up Subaru, yeah, so you recognize one, Subaru, you take a look at a Subaru car, you look at the stars in the front, it's Matariki. So where's our car called Matariki? Come on, we should get it. Just joking. So Subaru is the Japanese, you see, but this is Celtic, Hawaiian, Maka'ili'i, Islamic, etc., Chinese, but the Western tradition coming from the Greeks, called the Pleiades, or if you're a really boring astronomer, M45. So M stands for Messier. Charles Messier was an astronomer who just went through the sky and went, there's a fuzzy blob, number one, there's a fuzzy blob, number two, there's a fuzzy blob, number three. Got to Matariki, went 45, and so on. So there's about 106 of these. Galileo was the first to point a telescope towards Matariki, and this is what he saw. So you can take a look at the stars there, and you can match them up. They're there. Kind of went a little bit skew-if here with this, I think. That goes down in my eye, and this sort of goes that way. But anyway, Matariki has been known since antiquity, has a number of names and features in a wide number of cultural references. Here are the stars of Matariki. The people in this room will know them better than I. Oh, one thing I should point out. when you see images like this and you see these sorts of lines coming up from the stars, that's not real. So that is just an effect of what happens when you use a particular type of telescope to look at a star. So the rays of light coming out here like a cross in this sort of bluish circle there, that's just a distortion, if you like, of what happens when you use it. The stars don't actually look like that. They look like small pinpricks of light. In other telescope images, you'll see those spikes don't appear. I just want to reassure people that the stars actually are just like stars. So astrophysics. Matariki is what's called an open star cluster. An open star cluster is a group of stars which are all formed from the same giant cloud of gas and dust. They are a family. So the stars of Matariki they all come from the same stellar womb, if you like. They were all formed pretty much at the same time, the same place, the same cloud of gas and dust. So here's another open cluster down here, and you can see that there is like clumps of this dark material around the place. In this image, at least, this is the remnants of that cloud that gave birth to the stars in this cluster. This is not Matariki. This is just another open cluster. An open cluster, it's open because the stars are only just being held together, only just hanging together as a family, if you like. Other clusters can have like thousands of stars, but they're all very much more closely, tightly bound and clumped together. Matariki isn't one of those. It's an open star cluster. They are relatively young. This is an image of a massive cloud of gas and dust taken by the recent telescope which first started sending images back to us, the JWST, the James Webb Space Telescope. You might have seen it in the news. This is a $15 billion space telescope. And so it does do good pictures.
It's actually real.
This is not computer generated, this is a real image. This is a real image of the sort of environment where an open star cluster like Matariki would have come from. You'll see, for instance, there are nodules, like lumps like this, where the gas and dust are being squeezed together, closer and closer and closer. You get enough of that squeezing together, you'll get a star at the core of it here in the middle. So this is an immense cloud of gas and dust, and this is the sort of environment where Matariki or other open star clusters would have formed. And I'll move on because I could stare into this forever. But you can also see, again, you can see these sort of spikes here. They look slightly different from the other image. Also not real. This is how this telescope sees stars. What I want you to get away from this is that these sort of massive clouds, they're incredibly beautiful, and it's timely because we've only just got this. So here is a whole bunch of clusters which are similar to Matariki in that they are all open clusters. So maybe it's hard to interpret, but you'll see these stars, these are all individual groups of stars, separate families of stars similar to Matariki. They are beautiful. So if you have a chance to go see, you don't need a telescope to go and see these. I mean, Charles Messier did, he was with fuzzy blob number 1, fuzzy blob number 2, fuzzy blob number 3. It helps if you have a pair of binoculars, but you don't need to have a particularly powerful pair. Just go out, point your binoculars to fuzzy blob, and chances are you'll see something that looks a little bit like this. This is an easy one to see. This is the dual cluster, which is in the Southern Cross. So we always can see the Southern Cross, and this cluster is always there for us to see it. So it won't look like this with your naked eye, but it will look something like this if you had a basic pair of binoculars. Okay, so Matariki, where is it? It's in our galaxy. This is a cartoon of our galaxy because nobody's been out this far to go back and take a look at it. So this is what we think our galaxy looks like if we're well away from it. The sun is the yellow dot there, and Matariki is the orange dot, very, very close to us. It's one of the closest star clusters to Earth. It's about 444 light years away. That's about 4,000 trillion kilometers away. So it's far away, but still close. There's about 1,000 other open star clusters which we know of in our galaxy, but there's going to be plenty more. We just only know of 1,000. So Matariki is one of 1,000 that we know of. And clusters like this stay bound together for about a few 100 million years. Sounds like a long time. It's not. Not in astrophysics. That's a short period of time. So Matariki will, the stars of Matariki will likely disperse after 250 million years. They're all moving. They're only just held together by their own gravity attraction. They'll eventually just disperse out into space and go their own way. So for context, the solar system has been around for 4.5 billion years. So you talk about astronomical numbers, these astronomical numbers. Some astronomical numbers are bigger than others. So our solar system has been around for much, much longer than Matariki will last as a group of stars together. So here again, here's Matariki. And let's talk about what it looks like. You see them, they're a group of stars, and they're all, the ones that we see, look pretty much the same. They're all blue. In astrophysics, we categorize the stars, we give them particular types, and in Matariki, they are B-type stars. B does not necessarily mean blue. But relative to the sun, to Tara, these stars that we see in Matariki are hotter, bluer, heavier, larger, brighter, and rarer. So they are a different type of star to Tara, different type of star to our own sun. They aren't all exactly the same. There are different types of these blue stars in Matariki. There are giants, what we call subgiants, and main sequence stars. Basically, they're a family, and they don't all look exactly the same, but they have some characteristics which are similar. There are some members of this family which are huge, very, very big, the giant stars. There are some which are slightly smaller, still bigger than our own sun, and then there are some which are more like our own sun. So there's a mix. But typically they are, the ones that we see at least, they're all these beautiful, bright blue stars, which means that they're very much hotter than our own sun. They're hotter, they're younger, and they're not going to last as long. So the candle that burns twice as bright lasts half as long. That's Matariki. Those type of stars will burn themselves out much sooner than our own sun will. And so I've listed the stars there in Matariki, which are the giants. So Matariki is one of them. Waiti is another. Ururangi is a subgiant, so not as big as a giant, bigger than Puhuzakawa, for instance. So the takeaway from this is that Matariki, the stars of Matariki, are similar in some ways, but they're also different in others. So the stars that we see in Matariki, so this is a kind of, those are weird astronomy plots that you see, but the stars that we see in Matariki or recognize most easily in Matariki are the ones shown in blue here. So they'll be the ones that we can see here, shown in blue, but there are more than the stars that we can see with our naked eye or a small pair of binoculars in the cluster Matariki. There's about 1,000 stars in that cluster, most of which we can't see with our basic telescope or binoculars or our naked eye. And the way that we figure out, who's in the family and who isn't, is by looking at how they move. So you mentioned this big cloud of gas and dust that we saw before, the big orange thing. That's all moving through the sky or moving through the galaxy with a particular motion. And all the stars that it produces, all the stars that it births, if you like, they're all going to be moving in the same movement all together at the same time. So when you take a look at, the stars of an open cluster, you can see that they all move in the same direction. You might be able to see, it's hard. Does everybody see a little line coming from each of the dots? Okay, that's the star's motion. That's how it's moving. And you can see that a lot of them in this image are all moving in the same direction. That suggests that they're all coming from the same source. They're all coming from that cloud of gas and dust originally.
So does the location change?
Yes, yeah, they are moving, but they're all moving together. Generally.
Is it computer generated? Was it like time lapse? You know,
This is computer generated. I can show you a time lapse, another computer generated time lapse. But yes, you can get a time lapse of stars like this, but it will take a very, very long time. I can talk a little bit about these stars are moving, you know, a small amount over the course of decades or centuries, but we're still able to measure these very, very small movements over a human lifetime, and we can make these sort of predictions on how they move. If you took the sun and you took 800 suns, our sun, that's roughly the mass of all the stars in Matariki. But we can't see most of them. So we see the stars of the show, so to speak. We see the bright ones because they're big and bright and they're easy to see. Most of the stars in Matariki are much fainter and redder, and we can't see them with our naked eye or telescopes. They're very much fainter and redder, but we can still see them with a big enough telescope. We measure how they're moving. We will say, oh yeah, you're part of the Matariki family. And many of them are things which we can't actually call stars. So we take a big cloud of gas and dust and you let it collapse, crunch together. If you give it enough mass, it will become a star, like our own sun, or a star like Matariki, in Matariki. If you don't give it enough mass, it will turn into something like a big Jupiter. It's not quite a star, it's just close to it. And there are a lot of not quite stars in Matariki. You'll notice when you take a look at an image of Matariki is you'll see the sort of wiffly cloudy stuff around it. And this is the wiffly cloudy stuff that people like Charles Messier went, oh, fuzzy blob, number 45. It's fuzzy. Interesting. This is this blue stuff here. That is real. So the spiky stars, or the spikes on the stars, not real. The cloudy stuff, definitely real. That is a nebula. A nebula from the Latin meaning cloud. This nebula that you see here, this is what we call a reflection nebula. It's reflecting the light from the stars of Matariki. It is a cloud of gas and dust. But it's not thought to be a cloud of gas and dust from which the stars of Matariki was born. It's just a random cloud of gas and dust which Matariki just happened to be passing through at the moment. But originally it was thought that, oh look, it's the nebula, it's the leftover placenta, if you like, of the womb from which the stars were born. No. Current thinking is, no, it's just a cloud of gas and dust which Matariki is just passing through now and is illuminating, is shining its light on that we can see. And that gives us this beautiful nebula that we see. And so some young stars are often indeed surrounded by the cloud or bits of the cloud of gas and dust from which they were born. That's certainly true. It was thought to be true for Matariki, but now we just think, no, it's just a random cloud that's going through time.
Is that because it's traveling in a similar direction, but not quite exactly the same?
Yeah, precisely. Yeah, exactly. So everything in the galaxy is moving. We're moving on Earth. Earth is moving around the sun's moving around the center of the galaxy. Stuff is moving. And so, yes, at some point, well, currently, Matariki is just moving through this cloud of gas. And I don't know exactly, let's say 50 million years time, Matariki could be completely clear and have none of this cloudy stuff around it. Okay, let's talk about observing Matariki. So, as we know, we look for Matariki in the pre-dawn towards the northeast, around this time of the year, signifying the beginning of the Māori New Year. Celebrations occur around this time. It's a harvest celebration. Again, I'm quoting from this document here, so if this is not the local interpretation of Matariki, let's hear it. Okay. This is a standard researcher talking about stuff they don't know much about. They copy somebody else and then blame them if it's wrong. It's called citation. So, like I said, this is not my rowhead. This is not my area of expertise. again, my understanding. So the rising of the cluster signifies the start of the Māori New Year, Te Matahi o Te Rao. We now have a public holiday, which celebrates this, and this year is June 24th. This, the astronomy description of seeing something just before the sun coming up is called a heliacal rising or heliacal rising. So helios, the sun, Greek, heliacal, just before the sun. And so Matariki is chosen to be the last heliacal rising each year. I don't know the specifics of how Pauline and Rangi Matamatua came up with the code for this. I've yet to talk to them about it. But there is a way of figuring it out in the same way as figuring out the time of Easter each year. So, Pane Matariki, this is a pre-dawn scene around about this time of year as seen from New Zealand. Here's Matariki, here's Puanga, which we'll be talking about shortly, and this is Te Rā the sun. And so this is maybe an hour before dawn. You'd be looking out for the rising, the heliacal rising of Matariki in the northeastern sky. There it is, it's Matariki time. Let's talk about Puanga. So all iwi, I'm reading again from somebody else's words. All iwi celebrate the Māori New Year in June or July, but not all iwi refer specifically to this time of year as Matariki. Instead, other iwi will name this time of year Puanga. So here's Puanga, yeah, rising at the same time as Matariki. So Puanga, or as the Western tradition has it, Rigel, or Beta Orionis, again is a dazzling blue-white star. There it is there. This type of star, again, it's not just a giant star, it's a super giant star. So we're loving the terms in astronomy. It's like, it's not just a giant star, it's a super giant. To give you some context, okay, it is 47,000 times as luminous as the sun. It's a bright star. It's big, it's massive, and it's temperamental. It's a variable star. Its output of light changes over time. There's lots of beautiful physics.
Through a year or over a longer time scale?
I'll have to check on that. I'm not entirely sure. Some variable stars vary over the period of hours. Not big supergiants like this. They sort of like more slow because this is that much bigger. But yes, some vary over hours. Some vary over weeks and days. Some vary over months. So yeah, it changes its light output. And it's a multiple star. So it's not just one star, it's a group of stars. 4, possibly 5. So 4 definitely, 5 maybe. We'll talk about it in a second. I want to talk a little bit about the region of the sky that you see Puanga, because this is one of the first things that you see as a young astronomer. It's like, oh, what's the brightest thing I can see? Oh, well, Puanga is one of them. I'm going to look at that. You look at a star like Puanga through a telescope, it's like, unfortunately, even though it's 47,000 times the size of the sun, it's a supergiant, it just looks like another blue dot. So it's like, okay. What I find more interesting is looking at the sort of region around Puanga, which you can see there are these sorts of nebulae, different colored stars in clusters.
Which of those can you see with the naked eye?
There, this. So this is the constellation Orion in the Western tradition, shown the right way up, as in this is how we see it. Yeah. Every other image that you see on the internet is the other way up, but I've turned them all the right way up. So this is how you see. So here's there's Puanga there, which rises first. So Orion comes feet first over the horizon for us, but Puanga is leading the way. So yes, you absolutely see all of these stars, and we'll check out a simulation in a second. You can see what you'll be able to see. So the region in which we find Puanga is one of the most fantastic parts of the sky to look at for an astronomer, or even just looking in the sky with the naked eye. Full of these things which we've met before, these nebulae. You can see the like patches of nebulosity here. So these sort of cloudy, look like clouds, but aren't, these massive big clouds of gas and dust. And some of them are forming stars, and some of them are what happens when a star ends its life with a bang, literally, as a supernova, just blows itself apart and sends out a lot of its material back out into the universe. And that material becomes part of these big clouds of gas and dust, which then form the next generation of stars. So nebulas come in different types. You can see bright ones, which are either being excited by the stars around them and are sending out their own energy, some which are reflecting light, like the nebula that we see with Matariki, and some are just blocking light from stars behind it. So you can see there's a dark region here, for instance, where you can't see quite as many stars as here in this region. There's a big gap, and there's even a bigger gap here. There's a big cloud that's blocking the light from the stars behind it. This is what you see if you are obsessed with astrophotography. I didn't take this image, but I really wish I did. So, there are limits. This is sort of what you would see on a fantastic night with your naked eye, out in a really, really far away from the city, maybe with a small pair of binoculars. You'd see something like this. You'd see fuzziness here. You'd see this is a different color to this star. You'd see some fuzziness around here. If you took a pretty good camera and took a lot of your life and then stared at the same patch of sky night after night after night, and then added all those images together, that's what you see. So what we're seeing here again are these huge, huge big clouds of gas and dust, which are being shone on, illuminated. There's Puanga there. So you can see it without having amazing eyes that can collect all the light for 4 hours at a time. You can't see this stuff with your naked eye, but with a camera and a reasonable lens on the front, you get to see all of this detail.
So that's not enhanced, it's just captured.
This would be enhanced a little bit just to stretch the colors a wee bit, but the detail in terms of the structure, that's all real, yes. So the problem with, if you were just to take a straight up color image of this patch of the sky, it wouldn't look like this. Astrophotographers tend to stretch the colors apart a little bit just to, it's like a filter on your phone. It's like, I want to look great. So they would have chosen that just to stretch the colors out a little bit so you can see these regions as being slightly different. So what we're interested in as astronomers is looking at how the structure occurs, looking at, what on earth is this thing here? Why is that, a different color for a start? Why is it stretched out like this? Why is this thing such a massive, big, sphere? What happened there? Why is this a big round thing? Why is this a strip thing? Why is that dark? What are these strippy things here?
What's the other part one? The low one, the orange one.
This one here? This is Betelgeuse, or what we call Betelgeuse. I'm afraid I don't know the Terreo name for it. So this is a massive supergiant star again. It's much, much older, and it's likely to go bang relatively soon, as in, I don't know, a couple 100 million years.
Naked eye image on the right, is that the top one?
Is that one there? So that's Betelgeuse there. This region here is that star 3 there. This is that star there. There's Puanga there, up there. And so, yeah, I just want, there's so much more in the sky that we can't see with our naked eye, but as soon as we start looking at it with periods of time. And the neat thing is, you can get pictures like this with a fairly reasonable phone. It's really annoying if you spend a lot of money buying really good equipment. And somebody goes, look at this picture I took, and it's like, yeah, so no, it's cool. I got pneumonia last night because I took something worse than this. There's you and your phone going, oh. Anyway, so I encourage you to try it. Take your phone, set it. You have to hold it steady or just leave it or put it on a timer and just, and you'll be amazed at what you can see. Not guaranteeing this, but I'm guaranteeing something like this. Okay, so let's talk a little bit about Puanga and how we think Puanga is comprised. So the Western name for Puanga is Rigel, and we have discovered that Puanga is comprised of not just one star, but 4 at least. So Puanga, or Rigel A, is this massive big blue star, and it's this very, very big star. It's 100,000 times the mass of the sun. It's twice the temperature on the surface as the sun. That's why it looks blue and not yellowish like our sun. Around it, orbiting around it, is a pair of stars called Rigel B, Rigel BA, and Rigel BB. They are much, much smaller than Rigel, much, much smaller. And they orbit around each other in about 10 days. So they're really, really close, spinning around each other, and they themselves are going around Puanga itself. And then further out, there's Rigel C, which is smaller, but roughly the same mass as one of these guys. And that is also going around these two stars, and those two stars are going around Rigel. So it's quite a complicated system. With our own eyes, we can only see Puanga. We can only see one star. We can only see one thing. But in that system, there are more stars. So this is the region around Puanga. This is Puanga itself. So this is what we see in a telescope. It's like, huh, right. It is one of the brightest stars in the sky. Again, this sort of carry on here, not real. Everything else, fine. So Puanga is up here, and you can see there's an interesting region of nebulosity around it. There's Puanga there. So you can see with this image, no spikes. This is more like what you'd see with regular. But there's this fantastic nebula here. This is called the Witch Head Nebula, and I'm into these things. So this is what I try and take pictures of, right, when I can. But this is sort of the region around where Puanga is. It's extraordinarily beautiful. It has lots of detail, and there's some beautiful colors. So I'm going to see if this works. So this is a simulation. They're not real imagery, but it's a simulation of how the stars around Puanga will move over the next roughly 500,000 years. So like I mentioned, all the stars are moving around time. You'll be able to see Puanga in there somewhere, that you can find it yourselves. Puanga itself is not going to be moving much, but you'll see a bunch of other stars around it moving. And this is coming from a space telescope called Gaia. And its job over its lifetime was to measure the position of the stars over time. And taking that data and putting it into a computer, you can generate this sort of image, which shows you how the stars move. And so here we've got Puanga down here, not moving that much, but you can see other stars are moving with different speeds. Take a look at this crowd over here. That's an open cluster. You can see how they're all moving together. They're all born together in the same cloud of gas and dust. They all form and they all keep on moving together. Some stars move faster than others.
Do they crash into each other?
No. There's a lot of space. And you look at an image like that and you think, oh, that's really crowded. The space is really big. The stars themselves are super tiny compared to how far away they are from each other. Stars can crash into each other, but they usually are born together. Right. So they can form together like, let's go back to it, like this pair here. I'm not entirely sure what their future holds, but they can, stars like this can evolve together and become a single object. Now that single object, if it gets too big, they can just agree to disagree and they blow themselves up. So stars can collide into each other, but only if they are already associated in some way. They certainly can influence each other. So I mentioned before that star clusters, open star clusters like Matariki, are only loosely held together by their own gravity. The thing which will tear them apart is, for instance, here's an open cluster here. Let's say another star sort of scoots past them. It can disturb them. It can perturb them. It can shake them up. And they get agitated and they decided to go their own way. So the fact that stars move, even though they don't collide with each other, they absolutely can affect each other. And so you can see how things are moving in the galaxy. You can see that this star is not necessarily close to this cluster, just looks that way to us because it's lined up. But some stars will go close to this moving cluster here and disturb them, shake them up. And they can, as a result, fly apart from each other. Okay, have I got a little bit of time for? Right. So I'd like to just take you through a piece of software which I use. So people have the impression that, oh, you must use the best software. This is the best software. This is Stellarium. It's free. As in, it's free. You don't pay anything for it. If you've got a computer, you can download it. You can get it on your phone. You can play around with it, and there's lots there to fall out of it. I'm the sort of person who would prefer to have software free. You can go open source, freely available. It's a cultural thing from computer scientists. Won't go into it, but it's kind of religious. Stellarium is one of those fantastic pieces of software which was developed by a community who care about the software and maintain it. Works pretty much on any device, and we use it for teaching our students. It's just so good. So one thing you can do is you can take a look at Matariki and just plug in some of the dates and just see what happens. So let's go ahead and do that. Now, this is the point where the eminent visitor fools about his computer and it doesn't work. So bear with me if that's the case. When some stars get towards the end of their life, they have become, they are too big to hold themselves up anymore. So they have literally a collapse. They just collapse in upon themselves. And the physics tells us that when that happens, there's a point where that collapse can't continue, and there's a massive explosion and the star explodes. So that's the natural end of a particular type of star, including some giants, and pretty much all supergiants will turn into a supernova. So some of the stars of Matariki will end their life that way. Basically they'll get too big, they get too old, they run out of energy to hold up themselves and just collapse into each other and bang. Specifically what happened with the star of Matariki, I don't know. So I can look into it, absolutely.
It flashed and then it was a star that was missing.
Right.
And I was more interested around whether our children who always look at stars, whether some of the records that are from previous that time would have referred to those stars, and then later on when they're missing.
Yeah, absolutely. That's a sort of fascinating historical record which has occurred a number of times for supernovae, in particular cultures which have managed to hold the records over that length of time. There are records of supernovae from the Chinese records, because they wrote down everything and give exactly the same pathology. Something really bright happened there, and then there was a star that was there, now it's gone. Or in many cases, there was a bright thing there where there was nothing, and then there was nothing again. So that does happen in the historical record, and it would be great. I mean, if there are stories like that out there, we need to hear about them, because things which change in the night sky obviously resonated with the cultures who are observing them, because if you're relying on the stars and the objects in the sky to run your calendar and saying, well, this is going to happen next, and this is going to happen next, now it's time for harvest, now it's time for this, you're using that as a clock, as a calendar, and you want it to be the same every single time. If something just goes doing at the wrong time, you think, what's that? What does that mean? So Halley's Comet was one of them. So that appears in the Beta Tapestry. And clearly, in that time it was, oh, that means we're going to win the war. And the other people are saying exactly the same thing. So one of you must be wrong. So cultures will see these things, these changes, as being either good or bad, catastrophic or boons. So they pay attention to things which change. Okay, so this is sort of the dawn sky, just a little after Matariki. So let's bring it closer to Matariki. Hard to see, but it does say Puanga there. And there is that Witch Head nebula that I mentioned before.
Oh, it's there, yeah.
Whoops, there we go. So this is what you'll be looking out for round about dawn, just before dawn. So we run time a little bit further forward. Here comes Tara. And so that is heliacal rising, time of Matariki. Run time backwards a bit.
You can see why Tawid is the upper, typically with the upper.
And there's Matariki there. Oh, get over here.
And that stellarium, do you have to have it set up for the old Māori?
It comes natively, so to speak. Yes, you can put in. I don't know how many cultures there are in it at the moment, but it comes provided. You don't have to install anything special for it. So I couldn't get the font size right, but there are the proper te reo names for the main stars of Matariki in there. And I encourage you to have a play with this. It's a fantastic piece of software. It allows you to sort of predict. Here is just as Matariki is rising. One of the neat things you can do with the simulations, you can take away things that you don't like. As an astronomer, I don't like the atmosphere, so I can take that away. As a human, I really like the atmosphere because I like breathing, but you know, just gets in the way. So this is just at the point that Matariki is coming up over the horizon. There's Puanga there. This is east, and this towards the northeast. That's about 5:30 in the morning, and we can just run time further forward, and there's Te Ra there. But of course, this is what we'd see if we didn't have an atmosphere. But because we do have an atmosphere, we don't get to see the stars during the day. So this is, if you've got any questions about Stellarium, please just let me know. One of the things that you can do, one of the things that I'd like to see the community do some work on is, I don't know if this is right, what we're about to see. So there is Waka. I don't know if that's the right way up. I don't know. Is it? Okay, so one of the things about an open source software community is that if they're wrong, they want to know about it. So that's something which we can do. You can say, I think he got the boat up the wrong way. And if there are other
Is that all within the app?
yes. Yes, absolutely.
So you just see this at the pre-dawn and then it goes over us and then it can't be seen at any other time of the day.
At this time of year, that's right. So let me just take the walker away. Here we go. Yeah, so with the atmosphere on, because that's so it's still up there, it's just that we can't see it through the glare of the sun in the atmosphere.
So at other times of the year you can.
Yes, that's right. So let's go. When would be a good time? Trying to remember. Now I'm on the spot. I've got to try to remember when it's a good time to look at it. Give me a second.
So we're moving. That's like we were talking about this the other day. Who's moving?
Who's moving? Everything's moving.
Yeah, who's moving which way? We were trying to find it. It was saying, well, we're moving that way and it's moving that way.
Who's we in the story? So we're on the Earth.
Outside, 6 o'clock in the morning, talking about who's actually, like we were looking at the stars.
Okay.
And I was just kind of saying we missed this bit in school science.
I went through school science. I'm not surprised. Don't worry. I learned a lot of stuff not at school science. Okay, so let me start with this. So the reasons. Hang on. Where's my? There we are. Let me just go through. Let me just go to nighttime. Here we are. It's nighttime. So this is now about 10 to 10, sometime towards end of November this year. Let me just make time go a little bit faster. This is what the sky appears to do, right? The stars appear to move on the sky. So the stars aren't moving that fast. What's moving is us on the Earth. So the Earth is rotating on its axis around the sun, and we're all going around with it. What that looks like is that the stars are moving in the opposite direction. So we often refer to the stars moving on the sky, and as I've shown in the earlier video, they do, but over hundreds of millions of years, not over a couple of hours. What's causing that motion is us on the Earth, and the Earth is spinning. The reason why we see different stars in the night sky at different times of the year is because the Earth is spinning around the sun. Should we do a demonstration? I could do a demonstration. It involves volunteers, I warn you. You should. Yeah?
Well, I think you got the best volunteer over there.
All right.
Okay, I'll be the stunt.
Who was it? Okay, we got Chara. All right. Bright. The brightest thing in the sky.
Someone over there.
All right. This is going to work with you lot are the stars over there, okay?
Yeah.
I'm the Earth. My eyes are the telescope. Right? I've ruined the telescope. I've just looked at the sun. It's daytime. Daytime. I need a few more stars. Can I get some stars over here? Since you started this, so I've got some stars over here.
Is it one of the stars that is close? Close?
All right, so I'm on Earth. My eyes are the telescope. It's daytime. I'm fine. Okay. Nighttime. I can see these stars. At this time of year, as the Earth, I am doing this around the sun. So I'm going around the sun. And I'm spinning at the same time. Okay, so daytime, nighttime. Daytime, nighttime. Nighttime, daytime, nighttime, nighttime. Daytime, can't see those stars. Daytime, can't see those stars. Go forward half a year. Nighttime, can see these stars.
Right.
Daytime, can't see those stars.
Yeah.
Kapai? Thank you. That is the most fun I've had doing that, and I do that almost every year I teach with really reluctant first year graduate students. No, it's really, really hard to get this. It's really hard to get this right. So that's why in like half a year's time, if you as an astronomer wanted to take a look at Matariki and you want to get those good, cool images with the cloudy stuff, you don't want Tara, you don't want the sun in you don't want to do it at dawn because the light's coming up and it's like, I can't see a thing. So you go forward half a year when you're now with your back to the sun and Matariki is in that part of the sky which you can see. So here we have pretty much the same situation, is that here is Puanga up there, can we see it? There's Puanga, and Matariki is going to be over here somewhere, you said, trying to find it.
There where your arrow was down. Lift.
Thank you. It's time for a new prescription, I think. There's Matariki there. Now, as we go through this night, we can see that Matariki is going to, it's actually pretty much as high as it's going to go that night. So this is going backwards in time. You can see it gets to, so where are we now? This is this is about midnight. This will be the best time to be looking at Matariki if you're going to look at it with a telescope and not be bothered by the sunlight. So it's that's not going to help. So there we are. That's playing around with Stellarium. Have I got a little more time, or is it time to take a break?
What time's lunch?
That's important. Okay. So, back to the boring stuff, right? So, for instance, this is something which you can do with the tamariki who come into the marae. Busy. Get some computers in, that sort of thing I might be able to help with if it's necessary. Right? Running a stellarium session, that's something I'm more than happy to help with if you want it. Get them looking at playing around with this, because this works when it's cloudy. So one of the biggest disappointments. It's a terrible second place, but it's usually works. As one of the things about living with an atmosphere, it's got clouds in it, and Aotearoa is got a lot of clouds. Right. But this sort of thing just gives you a sense of answering those sorts of questions of like, why do we see the stars at different times and blah blah. It's actually really hard to get this because we live our lives thinking that nothing's moving. I'm not moving. I'm standing here. That's not moving. It's actually quite deep astrophysics, and it took all societies a really long time to get to that point of realizing that we're all moving. Earth moving, literally. Okay. Okay, so I'm trying to round off the talk just with a question, a challenge, an offer. I've made offers, doing the stuff which I can do anytime. Yeah, we can get that open again if you want. So, Matariki Puanga research. What does Ngāti Mutunga want to research? How can I help? How can, in particular, the University of Auckland help? And can I help, like, bridge any of these, start any of these relationships we want to? So I know Mitchell has been talking with our kairaki at the University of Auckland, which has been great. I don't need to be involved in that. I just want to make sure that people are getting what they need to develop the relationships, and say that there is an end user. The end user is this community. Okay, so when I came to take a look at the documents constituting iwi, I read the annual review. Yes, somebody did. Sorry. I just wanted to mention it because I have written many of these sorts of documents wondering who the hell's really going to read this. I've written many of these things, and I just want to shout out to the people because I know how much effort it takes to write one of these things. It's hard work, and you're wondering who's going to read this. People do. Okay, so I read it. I read the annual review. I read the strategic review. I read in that plan that this iwi wants to strengthen relationships with key universities. So I hope that the University of Auckland could be considered as one of them. If it's not, fine. That's cool. I've got friends everywhere. My job is not necessarily to big up the University of Auckland. It's to big up the possibilities that we have with this community and our research institutions. Right? That's my job. New Zealand's too small to be parochial about this stuff. So I read that and I went, yep, let me do this. And so back in April, I wrote to my boss, the big boss. I also wrote to his boss and said that, hey, look, guess what? Ko Ngāti Mutunga. What are you going to do about it? Basically, I'm here to be a bridge. I'm here to be an end user at the university and say, look, I want to see these links developed, and what can I do to help? And what's the process? And so Mitchell started taking that further forward, and that is great. So Mitchell's been in contact with Kairahi Tiariki Tuiono, and that conversation is going ahead. Just want to know when something happens. I'm here to help. And a key thing, I know this is getting away from Matariki and the stars and the fun stuff like that, but I want to point this out just in closing. When I apply for money from the government, in particular MB, which is the Ministry of Business, Innovation and Employment, so jobs, trade, there is an aspect called Vision Mātauranga, and that is a necessary part of any application. So when someone like me asks for money to do anything, I need to show how it develops Māori, or how it potentially could, or what am I going to do to help? Every single application. And this is one of the hardest things to figure out how to do. There are reasons for this, or reasons why people like me find it difficult, and why it's taking so long to get to the point where we're trying to figure out the best way of doing it. There's a lot of people around us who are extremely overworked trying to help us out. So this is part of the reason why I'm also here to say, well, okay, this is part of the framework of how we promote science, engineering, research in Aotearoa, New Zealand. So their statement, again, quoting from their own policy, we understand that Māori success is New Zealand success, and unlocking the science and innovation potential of Māori knowledge, people, and resources will benefit New Zealand. And there's a number of themes which go across every possible aspect which we can think of. I'm sort of kicking around mainly, well, Indigenous innovation slightly, Pio, the environment slightly. I'm not into health. Well, I'm not a medical worker, so I like my own health and other people's, but I can't do anything about it. And Mātauranga, so Indigenous knowledge and science and innovation. So there are several themes which I'm involved with, and this is how we're targeting this Vision Mātauranga. And so there are purposes, you know, from Vision Mātauranga, it's using the science and innovation system that we have to unlock what exists in Te Ao Māori and how to benefit New Zealand as a whole. And this is an important one, to recognize Māori as important partners in science and innovation, both as intergenerational guardians of significant natural resource, Indigenous knowledge, owners and managers of commercial assets, etc. Build capability of Māori individuals, businesses, iwi, hapu, wānanga, etc. And maximize the quality of the relationship between Māori and Crown through science and innovation in the Treaty of Waitangi. Okay, so that's covering a lot of ground there. The way I view this is like, well, I'm here to say, what can I do? How do we do things together? What am I doing which could be of interest to this iwi in particular because I have a personal connection to it? What are you interested in? How can I help? So it's a policy document, so it goes on a bit. Bringing Vision Mātauranga to life, specifically investing in Māori relevant science and innovation, developing Māori science and innovation capability, fostering connections between Māori government and the science system. So I feel that this is actually part of my job to do this stuff. I'm paid to do this, so don't feel sorry for me giving up my Sunday. This is my job. I love being here. This is fantastic. And here's supporting the development of iwi-led research and development strategy. Now, there's going to be things which this iwi wants to do, which I can't help with because I'm not a subject specialist. I can't claim to be everything to all people. What I can claim to be is I could be that person at the university saying, well, I've got people who've got an end use. Who's going to help? Right? I have no problem picking up the phone to my boss saying, how are you going to help? And getting an answer, etc. Okay, so this is very much the end. I know people are getting scratchy. It's getting close to lunch, so I'm just I just wanted to bring this one last thing to this community, just in closing. So you remember this? So cat videos from space, blinking lasers. This is the stuff which I'm mainly funded to do. We can see a problem immediately with this picture. That you can see New Zealand. There's no clouds in this picture, blocking this laser light. That's a problem, right? As soon as you have clouds, this whole thing doesn't work. So the job is you find some friends. Currently, my friends doing this work are in the other island, Australia, where they have a lot of sunshine. But they reached out to us and they said, oh, it would be really good if we had a group of the telescopes across Australia and New Zealand to make what we're doing better. So I said, yeah, sure, absolutely, let's do that. The idea being is you now have a network of these things all working together to provide the sort of service to get faster cat videos. But you're still looking for a place to stick this thing here, this telescope, and it will be good to put it in a place where there is relatively few clouds. Auckland sucks, not a good choice. I'm going there. Here's a bit of work which my collaborators in Germany did. They took some satellite data and said, where is it cloudy in New Zealand? And the answer wasn't everywhere all the time. Turns out we grow wine. You might have noticed. Pretty good wine too. Isn't it great that that's also the best place to put a telescope? Is a vineyard. Well, one of the places here, so this is a map of cloud coverage in the North Island. White, cloudy. Blue, not cloudy. Uranui is about here. In not terribly cloudy place. So if I was looking for a place to put a telescope, this area would be kind of cool to do it. So I've been looking for places. Here's a zoom in here. So Taranaki looks great. It probably actually isn't. This is probably just a glitch, but yeah, there's Taranaki there. But sort of around this region here, a strange little microclimate where it's not quite, not really cloudy. So there's a possibility here. I'm not saying it should happen. It's a possibility. This is what I'm looking for, and not just this project, but many projects. How can a research project fold in with aspirations of a local community? Okay, that's it. Thank you so much. That's been a long journey.
Tō reira tēnā tātou. He nui tēnei kaupapa mō Puanga, me te mōhio tonu ana no maira no kua noho tēnei tikanga I roto I a tātou. Puanga and this concept about this time of the year, the ending of one year and the beginning of another has always been a part of Taranaki's history. It's always been a part of our tikanga, perhaps more so than other places around the country. And so what I'd like to do is to talk about that. I'd also like to talk about the fact that while we talk about matariki and everything's out there as matariki, we have a huge challenge upon us to try and find out what is our kōrero from our region, because quite obviously the kōrero that has been gathered, that we have, tends to focus almost completely on puanga and less so on matariki. Kei te pai? I make the point, and mihia te kia koe Nick, that that is not my area of expertise. I'm not a stargazer. Although I do spend some time looking towards them, and particularly around some of our tikanga. I was a part of the advisory group with the matariki, and there were 7 of us on the group. So it was led by Rangi Mātāmua. So Rangi Mātāmua has been driving this for almost a decade, really, since he got hold of his tupunas, of his grandfather's manuscripts. So over in his grandfather's from Ruatahuna, and in Ruatahuna they had a surveyor that was working on the roads, surveying Tūhoi, and his name was Elsden Best. And at the same time as he was surveying roads, he was also gathering kōrero that then went into the Journal of the Polynesian Society. And one of the things he did is he identified a whole range of people through Tūhoi and other areas as well. Tūtaka Ngahau was probably one of the more prominent ones, but one of them was Rangi Mātāmua's grandfather. And so Elsden Best gave him a star chart and gave him a journal of about 500 pages. And his grandfather spent the next 30 years recording all of the information he knew and the others around Ruatahuna had about stars. And so that when Rangi Mātāmua took hold of the manuscript, he then started to work through it, because for a good 50 years it was locked up in a cupboard. It was just sitting there. Everyone was a bit scared of it. It was a whole lot of kōrero, not many people understood. And so Rangi Mātāmua definitely made a lot of that information accessible. It was never accessible before. Something like detailed analysis between, I think he said well over 500 stars have a lot of detail, where they rise, what the context in terms of a tikanga perspective of those. So that's the context in which the Matariki Advisory Group was started. It was actually supposed to be Che Wilson was the person that they were wanting to come onto the group, and then he was unavailable, so they turned to me from this area. So there were two. There was one person who was a Nick. That's Pauline Harris. So she's as Nick referred to. She was studying and is continuing to study in this area, and so she provided that information. We had Rangi Mātāmua, who had spent 10 years analysing the manuscripts alongside Rereata Mākiha. I don't know if you've heard of him. He's from Hokianga. Yeah. Rereata Mākiha has done a huge amount of work on the lunar calendar as well as the stellar calendar, the way in which the stars are read and the information around them. So those two people provided a huge amount of research and background from a Māori perspective. You had two navigators, Hoturo Barclay Kerr and Jack Thatcher, who are both renowned throughout the world as navigating by the stars with waka that go all through the Pacific without using any technology other than the kōrero that they've been given. So they provided that. And then there was Victoria Campbell, Tori and myself. We were there more from a perspective of tikanga and what a community's perspective of stars and annual calendars and how we operate in terms of tikanga. So koera te ropu. When we set up the kōrero, there were really five main things that the first one was obviously providing information about what knowledge we had into the mix. The other one was looking at what a holiday actually means, because there hadn't been actually a holiday. I can't remember the last one. Maybe we can. Anyway, it's been a long time since we've put aside a day for a holiday. And then on top of that, all of the discussion about whether it should be a Friday or a Saturday, and the fact that most of the holidays are on Monday. Oh, sorry, Friday or a Monday. Most of the holidays are on Mondays, which means a lot of people who don't get holidays on Monday miss out on that holiday. And so there's the whole idea about balancing. But ultimately, the idea of a holiday and the political environment that spoke to. The other one was, how do you actually calculate it? And it was an area that I didn't have a lot of expertise. I know how we calculate it in Pariaka, but it's different all around the country. Everyone uses different stars, so or uses different ways of calculating. So most of the time they look at the heliacal rising and certain stars, and then they look towards the horizon, and that gives an indication of the beginning of the year. So Matariki on the East Coast in particular is prominent because there's no mountains or hills in their way. They just look straight to the sea and they can see Matariki rising from that perspective. Other areas refer to Rehua, and there are a number of places, Hokianga, where Rereata is from, us, and some places in Waikato, not all of Waikato, but some of Waikato, us in Taranaki, in Wanganui, and some of the areas in Kaitahu utilize the rising of Puanga as the signal of the year. So how do you choose which, how do you calculate what are the holidays? There was a strong view that we shouldn't use the Western calendar to identify the date. So the idea is if we said it's on like Queen's birthday weekend is always on maybe the closest Friday to the Queen's birthday, rather than use that model, what is an inherently Māori model of calculating? We didn't have, in Taranaki, from what I saw, we didn't have a really well organized way in which we calculate it. In Pariaka, we simply look at the weekend before the 18th and 19th. So we look at the weekend before the 18th and 19th, which is usually around the 13th and 14th, around about that time. And then if you look at stellarium and other things, that is pretty much the time, pretty much every year, it's around about that time you start seeing Puanga rising directly above Taranaki. If you're in Pariaka and you look towards the maunga, directly towards the maunga, Puanga rises just slightly to the right, and then after a short while, it sits directly above, and it seems to just sit there for ages. But it probably doesn't. It's probably moving. And then yeah, it's all perspective. When we in Pariaka, the way we calculate it is when we see Puanga. If it's all cloudy, we sometimes do karakia and those other things, but we continue to go up there quite often until we see Puanga, and that's when we do karakia towards Puanga. But given that when we set aside a weekend and everyone's there, we still meet up there, we have our kōrero, we have mihi on top of Pūrepo as a response to really what was put on Pūrepo on the hill. That is where the cannon was, which was used to intimidate the people of our tupuna of Pariaka. So as a way of reclaiming the nature, the cope of that hill, as opposed to remembering it as something that was intimidation, into something that is empowering. So that's the way we look at. So this is a photo taken from the top of the hill, and this is Puanga. Later on, it was taken because the date that we had Puanga was a few days before it was cloudy, and this, as you can see, this is beautiful clear skies. And you can see, so you look directly east is where we look towards Taranaki, and we see Puanga rising directly above. Matariki is way over here and right on the horizon. So definitely Puanga comes up at around about the 13th or 14th, around about that time, and that's how we calculate it. However, that's not a very good way of calculating it because we're still using a very Western Gregorian calendar type of system. And so when you look at the way in which the year is set up, the Gregorian calendar, 365.25 of days. Né? That's why we have leap year, which adds an extra day on every year. If we use a lunar calendar, which we follow the moon, the lunar phases, there is 11 days out. And so every 3 years, and from a Māori perspective, we add a 13th month, which has a name. And the importance of using the moon to identify when things are, it means that everyone sees the moon in the same way. We all look at it, and it's a way in which the whole, your calendar isn't on the fridge, it's in the sky. You're looking towards the moon. Hopefully it's not too cloudy. If you're in Urenui, sounds like it's a perfect place to see your calendar. And everyone is able to identify when things are happening. Né? So according to Rangimātāmua and a number of other, there was a bit of research done, supported by Rereata and others, is that the normal phase that they looked at was the Tangaroa phase of the lunar calendar. So the Tangaroa phase is the final 3 or 4 days of the month when it's just about to head into the new moon. So when the completion of the year is in that final phase that you see the year moving on, and then once the moon goes completely from the sky, well, it's still in the sky, but we don't see it. We still can see it a little bit, but once we go through the new moon phase, that's the beginning of the next year. Yeah? So when we calculate when the date should be, because it changes every time, a little bit like Easter. I haven't got a clue how they calculate Easter. Someone explained it to me in one of the meetings, but I just went like that. But the way in which we calculate it, we look at that in the terms of the month of Pipiri, and we calculate the final Tangaroa phase before Pipiri. So it moves anywhere from the very last month, the last week of May, all the way through almost to July. So it moves, it's anywhere within that month, depending on which phase the moon is in, and it's on a Friday. We didn't have much choice around that because the government didn't want to change it just to one that would move from a Tuesday to a Wednesday to a Sunday. The idea was to be on a Friday. But one of the things that Rangimātāmua says that takes a little while to process is that one of the first colonizers of Māori was time. Yeah. Time was what colonized the way in which we structured and organized ourselves. And so the way in which we stopped planning and utilizing organizing our lives around the environment, looking at what was going on in the environment, linking that with the moon, linking that with the way in which we coordinated activities, then became a calendar based on 12 months of a year, 7 days of a week. The 6th and the 7th days is a day of rest, and then you have these. So the whole way in which the system of managing time is completely from a Western perspective of managing a population of workers. Ultimately, how do you manage a workforce, and then how do you manage that within a structure that is ultimately controlled by the people who establish that and can organize their businesses, their organization, their government you got the idea. what I think what we're talking about with Matariki, this day of Matariki, is that it is a reawakening of other ways of perceiving our environment in the Southern Hemisphere. So the first thing to recognize is that the whole calendar that we currently have in Aotearoa is based on the Northern Hemisphere calendar. It totally doesn't make sense to have the year starting in the middle of when you're actually in the middle of your year. The best time, and think about it practically, the best time to think you end your year when you finish all of the activities of the year, you've done all your harvesting, you've got everything in your rua, in your pātaka, and then you're ready to start moving into the new year that's ahead, where you start planning the planting and all of these other activities. Those are all the new year. So it makes sense that in the middle of winter, or maybe at the beginning of winter, is that point of the beginning of the new year. And that's ultimately what a Northern Hemisphere calendar is, because like if you were to go to Switzerland or somewhere like that right now, it'll be a lot warmer than it is here. It's because in December is the beginning of their winter. Fine? Marama? So this is the first holiday, it's the first day recognized in a significant way that recognizes totally a Māori perspective of the Southern Hemisphere and our whenua. A lot of people say, well, what about Waitangi Day? Well, Waitangi is about an agreement between the Crown and Māori, and it doesn't necessarily reflect what we want to see. Well, certainly with our experiences that the day of Waitangi is a lot of work to be done on it. So the idea of having Christmas and New Year's and Queen's birthday weekend and Labor weekend and all of these other holidays that have no real connection to Aotearoa is something that this day provides us. And so one of the things we had to do is to think about when it should be, and it shifts around. So this year it was on the 24th, and next year I've forgotten what it is, but 14th of July. So it moves quite a bit. Yeah. And then the next thing we had to do is to think about, well, what are the values that we want associated with that? There was a lot of response that came to the advisory from a range of groups that was saying, we don't want this to be over commercialized. We don't want a situation like warehouse selling a whole lot of plastic stars and then they go everywhere. And that is the norm from here on in, is plastic stars that are stuck everywhere. The reality is we can't do a lot about that. Business does what business is. So the only way really to counteract that is to have a strong set of values that are promoted over and over again, that become part of the identity of this country. So and for that reason, the focus of this period of Matariki, I use the word expression Matariki at the moment. So this period of Matariki is about the beginning of the year. It's the best time to plant trees, to do riparian planting and the like. You don't plant them in the middle of summer, they dry out and they die. So the whole idea about recognizing our environment, getting in touch with our environment, do riparian planting, but on top of that, the kai that you've grown through the year, making that available so that you eat what came from the year that you've just finished, as opposed to going down and buying a pavlova and the things from the supermarket. How about thinking about what kai your whānau has produced over the year, or what reflects tikanga associated with you? Now, some we use this expression hautapu, or te umu kohukohu whetu. So there are different iwi have different ways to do it. So a hangi, or cooking kumara, and then those are given as koha. There is a wide variety of behaviours of tikanga that is carried out around this time. And the main thing is that we didn't want to see the tikanga of maybe Tūhoe becoming the tikanga that everyone has to follow. What we need to do is that every region really promotes and encourages tikanga that are grounded in our area. And that was really the last main thing, but it was actually the first thing we discussed, was really about the name. And that we could call it matariki puanga rehua. It's a huge mouthful. Or we could call it te tauhou Māori, or all these other things. In the end, we felt that it's far better to just, even though other iwi utilize rehua, or we use puanga, it's not about which star we're going to have for the whole country. It's about what is a reference point that the whole country can use, and then allow and encourage each region to determine how they are going to do that for the new year. So the onus is on us in Taranaki to research, to gather kōrero, to be able to put substance into the new year that isn't just following like sheep what the rest of the country is doing, what other iwi that have stronger kōrero, a 500-page manuscript, or other things that give all of that information about stars. And as a result, we sort of get swamped by other kōrero. Now, one of the things that Rangi Mātāmua did is that within the manuscript, it talks about te iwa or matariki. So I just really want to go through some of the things the way we may look at it. Che is leading a research project with that Jamie, myself, and others are involved with, that over this next year, we just start gathering kōrero, and that by the time we get to Puanga next year, we'll be able to have wānanga and share far more in-depth information about what Puanga means to Taranaki and to Wanganui. Ne? Or just Ngāti Rangi. I don't know. We'll work out that. but there's some iwi have amazing repositories of knowledge, just mind-blowingly detailed information that you just wouldn't believe. And so there are pockets of information around. And I would pretty well guess, Jamie, that within manuscripts of Ngāti Mutunga, there is kōrero, or even just Te Atiawa Nui Tonu, there is really clear references that can become part of, instead of having a t-shirt that says Manawatia a Matariki, what is the sort of phrase that Ngāti Mutunga is going to use for the beginning of the year? What does that look like? And so what I want to do is go through some of the things that I found, and just talk about how they are an example of the sort of work that we have to do between now and the beginning of next year to put substance into Puanga for our iwi, our wider rohe, including Wanganui, and probably a number of other areas as well. Sounds like Rangitane have similar sort of kōrero. Moepoko apparently have similar sort of kōrero, so we need to pull that together. Fine? Okay, I'm just going to go through this. So this is, again, a photo taken from that when we went up there. This is a statement that Huirangi made within a karakia. E tuhi rā ko e uenuku I te rangi a newa. Ko matawero ko tautoru ko tāwere te petu takiata. I added ko puanga te tohu o te tau, because I heard people saying that, just to bring the karakia. And this is what our tupuna did all the time. They took karakia and they took sections of it, and then they adapted it and added into other kōrero to align a karakia with different kaupapa that were put forward. So the idea of te kairuri o te tau, kairuri is simply the surveyor of the year, the one who delineates the separation of one year to the next. Te kairuri o te tau, te kai aru aru I a matariki. I will say that a lot, because what this is it's puanga that drives or pushes forward matariki. It's not the other way around. It's not matariki that's driving forward puanga. Puanga is the star that rises above matariki. And as Nick showed in Stellarium, it's quite easy to see where that sits. Kapai? So I think, and this is just my suggestion, I know we're going to talk about it more, is that we need to have certain karakia, statements, waiata, pao, those other things that make these references that we start to teach and learn. And then once we start learning them, then they become a part of our oral traditions. They aren't new or made up. They are simply a gathering together of kōrero that we have in manuscripts that then become part of an accessible body of knowledge that everyone in our rohe will be able to utilize. So these are some of the references that I've come across. Puanga kairo, I tend to think of kairau are the kai that's in your rua. Ka rau atu te kai ki roto i te rua, that food that you have stored. There's other ways that that's explained. Te whata o puanga, the storehouse or the platform that you put your kai onto. Te tahi o pipiri, the beginning of pipiri, te kairuri o te tau. These are sort of statements that I think are going to become more important for us as, so this is a similar, it's the same thing as what you showed, isn't it? It's from Stellarium. You can't really see the skyline there, but you will always be able to find puanga. You'll never ever be able to forget where puanga is, because all you've got to do is look for tautoru, Orion's belt, né? And you just, the way that I tend to explain it, if you look at the handle of this pot and then you take the distance again above, it sits directly above tautoru, né? So whenever you're wanting to know where puanga is, just look for that pot, the Orion's belt, and then just look directly above it. All right? And then there's other stars, obviously, Taumata Kuku, which there's a whole kōrero about te kuku or te arupe, about a pigeon that rests in this area and then sits on this perch and eats puanga. Puanga is like a flower this manu, rupe, which is associated rupe with Maui and all this, that whole kōrero comes and eats from puanga. So puanga sustains that environment. That's, I suppose, the imagery.
As Ruakere said, we're going through these manuscripts, and it's amazing because the manuscript material is giving the narrative around some of these symbols with the manu and the fact that it references bird snaring, and so that traditional knowledge and how it sort of refers back to these stars.
And given that this is the time of snaring and the kereru are fat, having been through all of summer, and this is the time to make sure that you have your stores in place. You see this, ne? So this doesn't mean the negation of puanga. This is something we need to constantly make a point. Rangi Mātāmua talks about these stars as representing different aspects of the winds and the environment, the rain, the fresh water, seawater, those sorts of things. Pohutukawa for the mate, hiwei te rangi for the future. There is a whole narrative that has been associated with that. We don't necessarily need to follow that. We should recognize it, right? He kōrero tere. It's a kōrero, it's a narrative that other iwi carry, but we have very strong narratives about mate, and we've maintained those for literally for centuries. So we see that, for example, so we tend to start our recognition of mate on the 18th and 19th of June. Ne? 18th and 19th at Pariaka is our mate months. We bring the mate in, and then with the recognition of the mate, then we move into the new year. We do the same at Maui Pomare Day on the 27th, recognize the mate. So that it's not just coincidence simply that June is the month that we're looking at doing that. It's specifically identified that June is the month where we recognize mate, we have our kawe mate on that month, so that we can move ahead and whānau can move beyond. How many other marae do that? Or are the mate of Ngāti Mutunga, are they all going through to Maui Pomare Day? Is there a recognition of that role, of that tikanga? So the way in which this talks about mate of the past as well as the future, how it talks about the kai that comes from that's associated with the sky, the kai that's associated with the land. We already have those kōrero, it's just not in this type of imagery. We have karakia that have all of this kōrero. So what I'd like to do is go through some of those kōrero. I don't have a lot of the manuscripts that other ones have, but we do all have access to some of the research that's been done, such as the work that was done by Elsa Smith on the work that Kawi Kararehe did. And so I use this as an example. This is a line from quite a long way up the tangi, and you can see, those of you who've seen these words before, they are from quite a well-known karakia that's used throughout Taranaki. Most of Taranaki use this. tupua kaua ko tawhito kaua te mātoi o te rangi tēnei o ki rā te take rongo. You've heard maybe people reciting that karakia. But what te whare aitu does is he takes that part of the karakia to lead into the statement where it gets to the karakia and it talks about the sky. So he finishes off whakatupuria he kawaora, because he's focusing on well-being and life. And then the next line is he kaua kei te āpiti o te rangi. So at that point where the karakia starts to refer to the rangi, he then enters into this whole kōrero about stars and the different phases of the year. E tū puanga I te tahi o pipiri, huaina tō whare ko maru aonui, ki noho mai koe ki runga o rarotonga, nā te kāhuiua, nānei hoake, ka wehe te taururu e. Ne? So those, within that short statement of the waiata, you see the reference te tahi o pipiri, the beginning, the first of pipiri, with puanga there. You talk about the name of the house that's associated with puanga is maru aonui. And you talk about the star being associated with rarotonga, sitting above rarotonga. That's its celestial kāinga, place where it's from. And then it talks about this is the time of rain, not today. And then it says that the te taururu, ka wehe te taururu is the I take it that the taururu is that the winds, the heavy winds, and that the taururu. Or else it sometimes is referred to as a time of shelter as well, a time that you seek shelter. But what this is really talking about is that first month of the year. And so you start seeing using karakia or using waiata to record information that is around the calendar of the way that our tupuna manage their time. So this information is accessible to us. In the next stage, it says ka noho te takurua, ka e tū whakaahu. Whakaahu is another one of the stars. I'm not sure what the Western name of whakaahu is. On the second of Unuunu. And then gives the name of whakaahu, the star, as being te rangi aio. And this star, whakaahu, sits above Hawaii. Beautiful kōrero. These are statements that we have, that we're able to utilize and to have within karakia or have within waiata, so that our mokopuna will always be able to access the source of information and have it available to them. And then it talks about Takurua Nuku, which is another star being brought on by Takurua Nuku, and then from then we get the smaller stars, or maybe the other stars start to take prominence. These are the main stars, Whakaahu and Puanga. I'll just go through these relatively quickly. This is verse after verse after verse. There's a lot of verses within this waiata. So every verse carries information like this. Tautoru, this is the Orion's belt, Tautoru, gives that information. And carry on. Raikihi is another one. I haven't been able to identify which star that is. Okay, Raikihi. But Matangi o Rupe, these are all references that are used in a number of waiata. Sorry, Bob's all gone out on that. Carry on. The main thing is that the kōrero that was recorded by Te Whare Aitu is also reflected in Titoko Waru writing a letter. We're able to identify that the names of the month or these phases are different to the phases that we tend to use when we tend to say ko pipiri, ko hongongoi, ko hereturi koka, ne, ko mahuru. Those are the months or the kaupeka that are referred to nationally. But you can see quite clearly these are the references that are used within Taranaki. And then the challenge is, how do we use these? Do we start saying from here on in, Taranaki is going to say whakaahurangi or whakaahu, one of those two? Is that going to be our name for July? Or even is July the appropriate reference? Is it more about that phase of the moon? So we start looking at using these when we're talking about phases of the moon. And then the similar thing, we see that Whare Aitu starts to use these on hiri ngā nuku, hiri ngā rangi, unu pipiri. So they're all using similar days, periods of the month. They also associate the stars with the winter months are those times when of mate, and that's a time when te quite often will associate when there's a mate in your whānau. It's like putting your whānau into winter. You go into mourning, you go into darkness, and you enter the whare of apakura. So there are amazing kōrero about how we recognize our mate, and again, that's associated with the end of the year just gone, so that you can recognize the mate and then move into the new year. There's a few more. There's some these are the other names that are associated with the whare of apakura. And then further references. What a point that I'm making is we are not poor in terms of knowledge. We are not poor. Don't think that we have to follow matariki and the kōrero that everyone else is using and think that we don't have that. What the challenge is one is to still, what information do we share with the wider taranaki? What kōrero do we just retain just for our hapu and our iwi, so that this stuff is retained and it's protected, and then other kōrero may be just left just for those who carry the really in-depth kaupapa, whether that's karakia, tai, te kawa, those sorts of things where you need a far more in-depth knowledge. We almost need different levels of access to information, and then once we've identified that, and I'm just talking in relation to Puanga, then our whare will be strong. And when we're talking about celebrating, commemorating, recognizing Puanga at this time of the year, at the shifting of the 1 year to the next, then Taranaki and Whanganui and all of the other iwi stand together and have and are able to carry our presence nationally, because it is about nationally. Anyway, in doing ngā kōrero, this is another waiata, again referring to similar sorts of things. These here, the months, very, very similar. And actually, when you look at things like hiringa atamai, hiringa tahi, tahi te whenua, ketu, these are all about mahi to do with gardening. The whole, and you understand why the calendar, the lunar calendar drove what you're doing in the garden, because that was their survival. They needed to ensure that the crops were plentiful to be able to get them through the winter. So the whole planning was really organized around food production. Okay, and furthermore, let's come back to those more stars and reference the association of rehua as well. There's a lot of kōrero about rehua. The fact that when rehua is bright and strong in the sky, that's when it's summer. And then when it goes to winter, it starts to fade out of view, or it's not strong, and that's when it goes into winter. So when rehua is strong, growing of kai is strong. But it also references here that the water dries up and plants start to dry out. So it talks about planning. You need to look forward to these periods of rehua. Rehua brings the summer and growth, but it also brings lots of things that need to be recognized. Ka maro ki ngā tangata, when people dry out. And then it says kahinga te kāhui o rongo, which is your kai. Kāhui o rongo are the kumara that you grow in your mara, that you need to really be and protect them. And I just really want to now, so that's some of the stuff. There's a lot of work to be done in that area. And Jamie, I know that you've got lots of ideas around how that can be shared with Ngāti Mutunga, and I think we need to have wānanga. Be good to be able to have those as we get closer to this year, so that we can all stand together. But one of the things, this is Pariaka, obviously. There's a view of Pariaka, and this is a video. This is in Ku Klux Klan. You can hear Huirangi just talking about the fire, what its significance is, the ashes, the embers, what it does, and the smoke going to the into the stars in the sky. Yeah, the stars in the sky, and people as well. Papai? So you got the idea what's going on here. What this is taking tikanga, mihi, kōrero, waiata. I don't know so much about the bonfire, but there's, I think all of the rangata you got together and sort of put a lot more. Normally we just have quite a lot smaller fire, but yeah. The idea of what is the significance of an ahi, ne? What is the significance of the mihi and the karakia and the karanga and the all of those things that become part of a regular practice. And then, and this is about 3 years ago with Puanga. Kapai? It's still going. Anyway, there's a lot going on. So for the last about 15 years, Pariaka has made, in the past, it was quite a small group, and there would just be a few that would go up on top of Purepo and have karanga and karakia. And that was largely because of information that was shared to us by Rangi Kōtuku. You know Rangi Kōtuku, Rukuwai? So Rangi Kōtuku, a kaumatua from Pariaka, he said that when he was just a young child, he would got hoha when it came to Puanga, because he'd be pulled out of bed and early in the morning, out of his warm bed, and be dragged onto the marae. And if they couldn't see Puanga, then he'd have to go back to bed again. And then they would wait till they saw Puanga, and then there would be karanga and the other and then they would have breakfast. That was his account of what he remembers of Puanga when he was 94 when he died, and when he was just a young child, and he said he was hoha because he didn't make it anyway. And so the idea of recognizing it when we see Puanga is really what we've held on to in Pariaka. And about 15 years ago, it became a lot bigger, and now we get sort of 150, 200 people coming along. And the idea for us in trying to build tikanga around it, we start with the with karanga. Once the karanga are finished, then we have karakia. Once the karakia are finished, then we do a range of the poi that associated with Pariaka. Then we encourage people to sing pao. They might have composed a pao for Puanga or something to do with the year. So a pao was just a short waiata that it's like a ditty, and you're able to compose your own words to it. And then once that's finished, then we have mihi, and then ask anyone within the group to acknowledge any of their mate. So they call out the names of anyone who's passed in the previous year. It's hugely uplifting for whānau to be able to call out the names of those who they've lost in the previous year. And then once we've finished that, then we go down and light the fire. We have karakia and waiata to do with the lighting of the fire, and the fire stays on all day. So it starts from that point, goes all day. Then once the fire is lit and we finish karakia and the karanga and that's associated with that, then we have breakfast, and then we spend basically a day in the garden. So the idea of the garden is to prepare the garden for the new year.
Is it just garden, or what does it pertain to fish as well? The moon.
The reason why we've tended to focus on the garden is because it was such a strong element of what Pariaka did. The focus of production of food was a major focus for Pariaka. So this is just Pariaka's interpretation of that, and also the idea that by working in the garden, it actually recognizes that the whole calendar was centered around food production. And so the idea of clearing the garden is like clearing the space ready for the new, the next lot of mahi for the year. We didn't we don't so much gather kai, but people do bring kai that they've gathered onto the day. Quite often it's things such as if there's watercress or anything like that, they'll bring that and they'll put that through. There's not a lot at that time of the year.
I like the thing in the auntie, it could be a fishing day. Gathering kai from
So for us, we sort of build it around the idea of that it's the beginning of the year and we're planning food production and so that we can produce kumara. And we also recognized that when we had our reconciliation with the Crown, we referred to the reconciliation with the Crown as being te Puanga haiata. Puanga is the beginning of a year and haiata the beginning of a day. A new day within a new year, within a new focus of a relationship with the Crown. So that's how we associated that day of reconciliation. And this is taken on the day of the reconciliation. This is on top of the hill where we have our karakia from. All the tamariki going out to welcome the Crown and visitors that are coming on to the day. The idea of associating the Crown coming on as a contrast with the children playing games when the soldiers came into Pariaka. And our wahine taking kai to the Crown, again recognizing the day that our wahine took kai to the soldiers when they invaded Pariaka. Modako. This is our poi and our tamariki leading the Crown into the whakakainga. Here's rangi kōtuku that I spoke about. It was the first of our Pariaka whānau society.
Rangi Kōtuku's grandmother is Ngāti.
You get the idea. The significance of this is how it's associated with Puanga. And what Puanga adds in terms of value of this is it reinforces the idea of a new year, of a new way of looking, of a transition, point of transition from one type of environment in terms of the relationship with the crown to a new environment with a relationship with the crown. And so every year when we go through the process of recognizing Puanga, we're able to remember and associate that with these sorts of events. Even if this is on the 9th of June in 2017. Yeah. Okay. So this is our mahi within the Mara. This is what we do. So the idea of manawatia matariki, and had a bit of I won't go through that. There's a video about matariki, but if we think about what is the expression we want to use, ne? There are many different ways. We need to have a kōrero about that. What is the sort of expression we want to use? Kanui tēnā. He pātai, he kōrero rānei. We've got a lot of work ahead of us, and I hope that Ngāti Mutunga is supportive of this direction, and we'll be a part of when we stand in next year at the beginning of the year. We'll be able to do that all together, maybe in the sunniest place in the world. He pātai.
Pātai.
These could be stages of reclamation though, eh? Like it doesn't have to be one.
It doesn't have to be one, no. We can basically we can make it what it needs to be, and as long as we really all understand what we're doing and why we're doing it. These are just some things that came out of a brainstorm as to what we could refer to it as.
So the key thing, whānau, before Rua finishes is, I mean, we were going to have a wānanga after lunch, but I don't know, I mean, I'm looking at, and actually, ākoe nei ka tīmata tō tātou karangamaha Lani. So Lani's going to be starting with us in the 8th of August, cousin Lani. Lani's going to be driving a lot of these kaupapa for us. And so, but part of it really today was about thinking about how we as Ngāti Mutunga might reclaim, as we said earlier, or think about how we might want to engage with Puanga as an iwi, but also think about collectively with, as what Rua was saying. And you know, there's a bit of research that is being done at the moment. As Ruakere said, a group have come together, Taranaki, Wanganui, drawing upon a lot of our manuscript material, a lot of our waiata, our karakia, to inform how we might bring that together to enable us to give expression in a contemporary context, our understanding of Puanga, but really to make it relevant to us today and how we carry that forward. The other theme, of course, with Marlene and the team, cousin Sammy and others, you know, we have our kaupapa centered around the taiao, Te Kohanga Ahuru. We've got Te Aro Te Ata, which is the big mouth messenger. process that our Ngāti Tama whānau, which we are a part of, will undertake. You know, I'm looking at Huia and I'm thinking back to the late 80s, you know, when we had our mara here at the palm. You know, it's just as you were, you know, sort of my memory was going back to that time. We had the community was engaged, right? And we had our mara. So I think it's, you know, this stuff is not new for us. It's actually sort of, carrying that forward. So that's some of the thinking. So, and really encouraging those of our whānau that are keen to be a part of developing up what these initiatives or what this might be for us is really, really where we're at. And I think, you know, the mahi that Rua and our whānau at Parihaka have done and how it's with, you know, Puanga's, we've always had, you know, that transition, you know, this June, and it's not new to us, but it's really how we sort of reclaim that. In recognising, you know, we had our 18th and 19th here. You know, Pomare Day is our day for our tupuna. So it's not new, but it's how we take that. But I see Puanga as a way of bringing us together. It's not only Ngāti Mutunga, but Taranaki as a whole, a time to celebrate and acknowledge who we are. So any kōrero or any other part-time kōrero, Kire?
Just add I've got my Pariaka side there. But you know, I just want to share, as a kid growing up here in Pariaka, this is with lots of memories. We were kids, my name had the biggest marakai out there. And our role, when we were PFS and that, was to what you would call today is grading the kai, you know, the taiwa and that. And the little taiwas would go in this bin, and then the next size, and the big ones in the last bin. And they were the kai that came out to Te Atiawa. My nanny and koro would go around and take kai around in those days. And we used to prepare those gardens with them and get the marakai and they grow. And then when they were all ready, was our role again to, like I say before today, grade all the perimeters, the taiwas, you name it. And I remember we used to have a hole in the ground where Danny would put the watermelons in the ground, and we used to have the dry food that used to cover the kind of it, and even in the bin. So, you know, and even looking at the bonfires, the fires and what has been presented this morning. When we were kids, we had those bonfires, but to us they were just like the guidebooks. But what I'm saying today is that we didn't have the meaning of that when we were growing up. To us, they were just bonfires. Yeah, they were just bonfires. And like I said, the marakai, and I know my nan, even though she was Ngāti Mahuta, and was married to my koro, that was her role at Parihaka. And even when it came to the Rā days, and when we talk about Puanga, man used to say to us, and kia tātai te manahiri, me koe o kia. Man used to tell us to go out and look for the three sisters. You know, when you put that thing up there this morning, I'm looking and I'm thinking, oh, must be those three sisters. The three sisters we used to look for. And it was the Milky Way, you see. There were other names that we had for those stars that man used to tell us to go out and look for. And so, you know, I'm really pleased I came this morning. I'm looking at those three stars. must be the three sisters. And I was looking at this other cluster over here and think, oh, that must be the Milky Way. So, you know, I'm just really, I think I've trained this morning. And this is about March over here, and I came out to Switchdown yesterday just to confirm it. I was thinking of those sorts of things when we were kids growing up. But I know that my nan really worked hard at Puanga, and we only stayed in Topi's house when we were kids. And that was because it was easier for Nan for us to set the tables and do all those sorts of things when we were kids. You know, I haven't grown much taller now. And my job was all I could do was walk along the forms and set the table like that, because I was looking for I was sure to come out all the more. So I used to have to walk along to do the tables. But we used to do that, and especially when we talk about Puanga, I just think I just had it before, but I just missed it. I know we had another name as kids growing up when we had to look for the stars. But I always remember that bright star when we were kids. Because Nan always used to say, you go and look for the bright star. And the meaning of that for us, it came to Puanga, it was about the mother, it was about feeding, it was about crying for the iwi down the mountain. There were times when I know Nan and Kuro would send kai down to South Taranaki too. So I suppose lots of memories have come back from when we were little, and sort of now putting the two and two together like the Milky Way. I just want to say lovely to be here, and to how we were brought up in Puanga in the early days.
Yeah.
I just say about Uncle Ben, all those nannies and everything that used to sit there. But I know he used to work very hard doing the marakai most days as little kids.
Interestingly, you know, back in the day, talking to all of our paake, so our kuia, our big day, the biggest calendar day for Mutuna since the passing of Tāmaui was Pomare Day. It was the major sort of day for Ngāti Mutuna to uphold the tikanga of that day. And so, you know, all of the families with all of their best kai would be prepared for the year to go into Waitara. And that was just how it was. It was all building up to Pomare Day. That was the sort of, which is not too and it's this time of Puanga again. But when you think about it, you know, talking to all of the aunties, you know, who were since that day, the whole sort of their planting, the gardens, you know, going yelling, everything centered around Pomare Day. And of course, the biggest, you know, one of the tino kai I te rawa, ko te piharo. So, you know, the piharo was the sort of prized kai at that time of year. And just yesterday, when we were having Auntie Silla's unveiling at Wahapakapaka, I was talking to Uncle Stevie Maxwell, because I said to Uncle, I said, oh, how's the piharo been going this year? And he said, oh, it's the fourth year, because every fourth year, piharo seemed to not sort of be as abundant. Like last year, he said he caught about just under 1,000. He's got 4 this year. But he said, but that's about right. And then that's on the Waitara. And I said to him, I said, oh, well, Uncle, we probably need to think about our piharo here in Uranui. And he said, yeah, I know where Dad used to fish. And so this is really just a karanga. I was just thinking with Uncle, because Uncle's not getting any younger. He's certainly not getting any better. But just tying into this around, you know, the practice of piharo again. And then with talking with him yesterday, thinking about getting a like-minded group, so those that are interested in the piharo, to identify particular areas along the Uranui. So he gave me the description of those areas that you've got to identify during low tide. And then, yeah, so that's just another part. We will probably get a little group together who are keen to start looking at that. But I want Uncle to start talking about the practical elements of, you know, how you set, and Uncle Henry too, but cousin Audra tells me Uncle's been a bit busy.
He's been a bit busy with other Stevie.
But that's just got me thinking, as Auntie, as you were talking about our parihaka, but you know, so that might be again, you know, we're not sort of engaged as much as we used to in Pomare, but again, you know, sort of understanding Pomare Day really for us is a time to get, although it's about acknowledging our tupuna, it's a time to, as Ruakere has said, you know, farewell our mate for the year. But it's the theme of Pomare Day has been very much about health and well-being. But again, how do we sort of engage more strongly as an iwi as we did in the past? You know, it's wonderful talking to all of the aunties, Auntie Lena, Auntie Jean, Auntie Marge. You know, Pomare Day was the day, that's when Mutunga put on their number ones.
Yeah.
Velvet hats, the white feathers. Yeah. So I just thought about that, yeah, and the other thing, piharo, because they talked about the piharo really, you know, the first you needed the cold water, so the first sort of duka matahi, first lot of snow, and then those heavy rains, that heavy rain to sort of flood the water. So yeah, that's not quite going out fishing on cousin Brett's boat, but piharo sort of piharo and then gardening. Any other whakaaro?
Found it interesting that that was talking about ngā kāhui or puanga. So that whānau there, which they've identified up to 4. We probably have our own identification for those names too, would we?
Yeah, I think what we need to do is to understand better those manuscripts and what they're referring to at different stages. So stellarium definitely does help, because we can go to that month of the year and see what where the stars are and what they're doing. Yeah.
Yeah, I'm quite excited that we've still got a resource there from within our kōrero o mua kōrero.
Yeah, so the thinking is, Hemi's done a bit of work. So Hemi's sort of and Che, so Hemi's mapped out sort of our calendar, Taranaki, because it's largely the same, but there are slight differences. He's done that. The stars you see, and in particular, you know, what activity you might be doing in particular karakia, and then waiata. So it's lovely because we've got Potete singing some waiata which reference Matariki. So Potete, Uncle Steve and Uncle Peter's wife's father, singing a couple of waiata which are quite, you know, aligned with sort of periods of the year, and then there's pau, and then even sort of composing new karakia and waiata and pau, and then it'll just provide it. But we're early days, they were just that understanding, but that's all part of the process.
Can I just say that on the day, that was the day also that you had the best of kai. And like when you talk about the pihara, could be white back, could be kai moana, and it was on those days was a special kai day for ngā kawe mate, and that they're coming, and those who are coming, and it was to help that healing. They come with their kawe mate, but then when they leave, they go back with open hearts, full hearts and things. And that was also, I think, it was always a special kai on that day. When I was talking about piara, and that's what they used to have on the table. You name it, it's there. You don't see that today.
It's exciting time.
Good point. Do anything else we need? Huh? But this is really just the start. I know we just thought, you know, we thought it was sort of perfect timing. So with our whanau and Nick, and his mahi, I mean,
Yeah, great.
just blows your mind, right? And so, you know, that we've got one of our own that's working and operating in that space, so we're going to take advantage of Nick's mātauranga and then the mahi that Burkett has been doing at a national level and then also locally. Really just setting some context for us as we, as Ngāti Mutunga, start to understand, you know, what we want and then how that might link into certain mahi that we do collectively. And it's probably timely as we're sort of working through the redevelopment of the park. So we've got some big plans and housing and all of that, but also building our community again. So, so we've got another koha for Rua. I'm not going to drop this one. And so Rukere talked about the fact that ko te wā tēnei o te whakatō rākau, and I should actually have Marlene talking more about this than I, but he pohutu kawa tēnei. And so you all remember myrtle rust. So myrtle rust threatened the pohutu kawa, and the pohutu kawa here in Paparoa, sort of here in Ngāti Mutunga, is very unique and old. And there are narratives that go back to Te Tainga Mai o Tokomaru, so narratives that link back to the arrival of our Waka Tokomaru. And so this is one of those cuttings that were taken, and yeah, it's just Marlene and the team 6 years ago now. And so next weekend, whānau, on Saturday the 23rd, there's an opportunity. Is it next weekend? Yeah. Next weekend, Saturday the 23rd, those of you that are available and keen to go out planting, there's going to be a planting day for our pohutu kawa. I know you do it. Nā mihi. Ka pai. E kōrero anō? I anō? Oh, well, ka nui ngā kōrero I tēnei rā. So I think it's probably enough for us. So we'll end today with the hakare, our kai. And so there's an opportunity to have some further kōrero over lunch. And I think sort of post-lunch or post today, if there's anything that, any new ideas you have or thoughts, feel free to contact the office, talk to Mitch. As I said, our whanaunga Lani is going to be joining us in August and driving a lot of our engagement kaupapa with our whānau. And so looking forward to Lani joining the whānau at the office. Yeah, so that's us. And, you know, as we've always said, we've still got our karakia wānanga going. And, you know, e tahi o koutou, ko piri mai ki tērā kaupapa. So, and then our paipai wānanga is going well. So we've had a good group sort of attending our paipai wānanga. And we're going to be setting some dates for our noho marae. And although we've got the group that have been participating, that will be open to any of our whānau that want to come along and participate. Nō reira, me mihi au kia koutou, kia tātou, kia koe Nikora, tatu atu rā kia koe rua, me mihi ana kia kōrua mō ngā kōrero, ko ora ia nei, hei kai mā te hine ngaro me te ngākau, o tēnā o tātou. Nō reira me whakakape ake tō tātou ui. Me mihi ana kia koutou, kua hono mai mā tipurangi. Poeno, kua rere ngā kōrero, kua rere ki uta, kua rere ki tai, kua rere ki te hine ngaro, ki te watu manawa, o tēnā o tātou. I nai nei me wakairi ake te ki te kōrero, ki te tā uu o tō tātou ware, te aroha e tūnei. Turuturu o uti waka maua kia tīna. Tīna. Au me uie. Ai. Ka pai, kia ora tātou.